everyone, welcome to the channel. My name is Unim Mufawasi, Faculty of Biochemistry, University of Lyon. My group and I will be discussing on how to run Agarose gel electrophoresis page. Hi everyone, welcome back to the channel. Today we are taking you into the molecular biology lab to explore two essential techniques, Agarose gel electrophoresis and page, also known as polyacrylamide gel electrophoresis. If you ever wondered how scientists are able to separate proteins or DNA, then I think this video is for you. Let's jump right into it. First off, we're going to define electrophoresis. What is electrophoresis? Electrophoresis is a technique that uses electric currents to separate molecules based on their size and charge. When we place a sample into a gel and apply an electric current, the molecule begins to migrate. Negatively charged molecules move towards the positive electrode. The gel acts like a molecular sieve. Smaller molecules travel faster and further, while the larger molecules move more slowly. This is the basic principle behind all electrophoresis techniques.
Okay, let's begin with the first technique, which is the agarose gel electrophoresis. So this is the most commonly used method for DNA and RNA. The gel is made from agarose, which is a sugar polymer extracted from seaweed. When this agarose is heated and then cooled, it forms a flexible gel with pores large enough for nucleic acid to move through. So now, I'm going to give you guys the general idea of how the process works. So firstly, an agarose solution is prepared and poured into a casting tray to form the gel. And then wells are created at one end of the gel, and this is where the DNA sample are placed. The gel is then submerged in a buffer solution inside the electrophoresis tank. Once samples are loaded, an electric current is applied. DNA, being negatively charged, moves towards the positive electrode. Smaller DNA fragments move faster, while larger ones lag behind. To visualize the results, the gel is exposed to a DNA binding dye and viewed under UV or blue lights. The binding pattern shows the size and quality of DNA present.
Now let's move on to polyacrylamide gel electrophoresis. While agarose gel are ideal for DNA, phage is mostly used for proteins or to separate much more smaller DNA fragments. The gel is made up of polyacrylamide, which forms a much more tighter or more uniform method than agarose gel. This gives phage its high resolution. It can separate molecules that differ in size by very small amounts. Phage often evolves two layers of gel. A stacking gel, which lines up all the protein sample neatly into a sharp band. Resoluting gel, where actual separation takes place. When running an SDS page, the most common form of proteins are treated with a detergent that gives them all a uniform negative charge. This means their movement through the gel depends mainly on their negative charge. Just like agarose, the gel is placed in a tank, samples are loaded, and an electric current drives the process through the matrix. After the run, the gel is stained and to reveal distant protein bands.
Now, let's talk about the two differences between agarose and page. Being the two main types of gels used for electrophoresis. First of all, agarose. Agarose is a sugar-like substance made from seaweed, which when cooled down creates a gel with big pores. These big pores are perfect for the electrophoresis of DNA and RNA molecules, since they themselves are larger in size and need a gel with large pores for the electrophoresis for the molecules to pass down easily. Think of it as a fishing net with big holes for sorting big fish. And we can also talk about page. Page is basically polyacrylamide gel electrophoresis, and it is made of chemicals, two major chemicals, acrylamide and diacrylamide. It's a gel with tiny holes, and it is used for the electrophoresis of mostly proteins or smaller molecules of DNA and RNA. if we want to speak on the key differences, first of all, it's the pore size. Agarose has a larger pore size, while Page has a smaller pore size. Their use, agarose is used for the electrophoresis of DNA and RNA molecules, while Page is used for the electrophoresis of protein molecules. And if you carry out electrophoresis with Page, the end result is more detailed and specific, better actually than that of agarose, and it is actually more technical to carry out than the electrophoresis.
In conclusion, the page and agrogel electrophoresis are essential techniques in biological science. They allow us to analyze, compare, and understand the molecular component of cells, whether they are DNA fragments or complex proteins. As we have seen, while the principle behind the technique and similar, the materials, application, and resolution differ significantly. Understanding these differences helps researchers choose the most appropriate method for the experiment.